This lesson is on linear inequalities, and it is section 9.1 of the McGraw-Hill-Ryerson Pre-Calculus 11. The following are a list of things that we expect that you should be able to do by the end of the lesson. We are covering RF7, and I would encourage you to stop, pause the video, rewind, do a question, and then catch into the video to see what the answers are, so to be an active participant in the learning. We are looking at outcome RF7, as I said, and that looks also at graphing linear functions. So prior knowledge is looking at graphing and solving linear functions, so be able to draw a line. Well, let's begin. I'm going to start with a little bit of a reminder. This comes from probably grade 9 even. So let's say I had something like this on my number line, where I have a hollow dot, and I have shaded it to the right. What does that inequality look like? Well, that inequality, if it's looking at a value of x, we're saying x is greater than 2. The hollow dot is representing that there is no or equal to, that that number is not included. So if we look at something similar, but a little different, here now I have a solid dot. So this inequality would represent x is less than or equal to -1. So the solid means that that point is included, and the hollow means it's not included. We're going to do something similar, except remember we're dealing with linear inequalities. So this topic is on linear inequalities. We're dealing with linear inequalities, we are dealing with lines. So we're going to have something very similar to this. We're going to have a solid line when the values are included. When the values on the line are included. Well, what does that look like? That would be a less than or equal to, or a greater than or equal to. So it has the or equal to part. We're going to have a slotted, that's what I call it. Some people call it a dotted line, a dashed line, slotted, dotted. When the values on the line are not included. So if they're not included, we don't have an or equal to, we just have a less than, or we might have a greater than. So when we're drawing the lines, we need to be aware of that information. Let's look at this example. It kind of helps if we get into an example instead of just having a whole bunch of notes. We have a couple of things going on. We have a linear equation. We have 2x plus 3y is equal to 6. But we actually have a less than or equal to. So two things. We're going to graph the line so we get the points for our line. So we go about how we're going to do that. And then we can also look at that inequality, what it means. So I am looking at this as 2x plus 3y equal to 6. I'm looking at it that way first because I just want to get the line. And the easiest way for most of these is probably going to be to put slope-intercept form, slope y-intercept. Most of these questions will have an integer y-intercept. So we're isolating our y term, and this requires I have to divide every term by 3. So I have y is equal to -2 over 3x plus 2. Now, technically, it is less than or equal to. So you can keep that inequality in as you're doing the math, especially because it's going to affect, some signs are going to affect that inequality. Now we're going to plot this, knowing that this value is the y-intercept, and this value is going to give me the slope. So we're just going to plot some some points. So here's a point, that's our y-intercept. Here's another point. Noticing going down and over 3 to the right, I'm going to go up 2 and over 3 to the left, get another point. Now we have to draw the line. This is where that inequality comes into play. So we are looking at this inequality right here, and it has less than or equal to. So that tells us the type of line that we're going to choose. We're going to choose our solid line. Let's straighten it up a little bit here. Now, we have that part, but what does it mean for it to be less than that line? And that's a little bit different. We need to deal with a shade, and I haven't talked about that. I want to demonstrate it. It's the values that are less than that y value. So we are looking at the point we have is our y value here is at 2. What are points less than that? Well, here's -2. It is less. So this is the region that needs to be shaded. And to show you what the shade is, it's all the points, including the line. The solid line tells me that it's included. And in this particular case, it's below the line. They're the y values less than this line. So that whole thing, the line and the shade, the answer. The shading part is called our solution region. All of these points that are in the shaded area are part of the solution, including the points in the line. Well, here's the question based on the line that we have. It's asking, is this point part of the solution? And there's 2 ways that we can answer that. Let's look at the first one algebraically. We have x is -2, y is 4, and we have an inequality statement. Now, I'm not putting an equal to, and not putting a less than or a greater than, because that vertical line I'm putting in is just saying I'm going to treat my left-hand side differently than my right-hand side. I'm just going to find those values. On my right-hand side, it has to be 6. My left-hand side, is 2 times -2. Plus 3 times 4. So that's -4 plus 12, which is 8. And back to my inequality statement, it says that this is less than or equal to 6. So my question for you is 8 less than or equal to 6? No. Therefore, the point -2, 4 is not part of the solution. So this is answering the question using the algebra. Well, how can I answer that question another way? I can look at it graphically. The point is -2, 4. Let's go back to our graph. So if we find the point -2, 4, is it in the shaded region? No. Therefore, it is not part of the solution. So if it's already drawn, you can tell that point from your graph. If it's not already drawn, you can determine that algebraically. So here are a few notes. Solution region we talked about. We talked about the boundary line, the line that's separating the plane and the regions. So it could also be a curve. We're going to look at parabolas as well as lines. They're a quadratic function. Solid for the less than or equal to, greater than equal to, the dashed or the slotted line for the less than or just a greater than. And then we have a test point telling me if that point is part of that solution or not. So here is a question for you to do. So take a moment, Pause, do the question, and then we'll check your work. Once you've drawn this inequality, it should look like this one. And then I had the point was 1, 3. And notice where the point is. The point happens to be right on that boundary line. In this particular case, it's a solid line. That means that that point is part of the region, the solution region. Okay, example 2. We need to graph. So let's put this into y equals form, or slope y-intercept form is the correct terminology. And we have an issue right here, because the way I have done this is I now have a negative in front of that coefficient. So it's a -5. And I'm going to divide every term by -5. But that is going to affect my inequality statement. So we know that that now is y is going to be less than 2x. So we've learned that in grade 9. All right, so when I'm dividing or multiplying by a negative, the inequality switches. Okay, well, what does this look like? What are the points? Well, I have that my y-intercept is 0. In case you haven't realized it, there's nothing listed. There's a 0 there. So my y-intercept is 0. My slope is 2. The question we need to ask, is it a solid or a slotted line? In this particular case, we're going to have a slotted line. And I just find it easier if with the line that we have, that you extend it using the full part of your graph. Now we have to look at how do we shade. It's less than, so I need a value of y less than 0. So I'm looking, okay, -3. That's less than 0. So this part needs to be shaded. I'm moving my pen, but you can't see it. So let's get this. This part needs to be shaded. So we're shading below the line, less than. Why don't you give this one a try? Oops. When you do your shading, you should have a negative slope. This one also has a y-intercept of 0, and we're shading above the line in this particular case. So this is the greater than. Example 3 is like the opposite of what we've been doing. Now we have the inequality statement and the inequality graph, and we need to write the inequality statement. So first of all, we need to know what the equation of the line is. We will need to determine the inequality based on the line and then based on the shading. So when you're finding the equation of a line, you're really looking at y is equal to mx plus b is an easy one to start with. Remembering that the b is representing your y-intercept. The m is representing slope. So in this particular question, my y-intercept is here at 4. When I go to look at slope, which I have, I can go from this point up to here, so I've got up 2 over 1, so that's a rise of 2, a run of 1. So my y-intercept, let's just write it out. We said y-intercept was 4, and it looks like our slope is 2 over 1, which we just write as 2. So what is our equation? Y is equal to, because we're used to the line, 2x plus 4. If I was just having a line, that would be correct. But it's an inequality. So it's going to be y something 2x plus 4. Well, we know that it doesn't have an or equal to because of this line being slotted. We know that it's either a less than or it's a greater than. I take my y-intercept point that we have here at 4, and we want to know, are those y values less than the 4 or greater than the 4 in the shaded area? Well, below is in the shaded area, and that's a 2, and a 2 is less than 4. So for me, that's saying y is less than 2x plus 4. This inequality statement represents the graphical representation that we have. I want you to try this one. And you come up with the equation that fits this inequality. We have a y-intercept of -4. Looking at my slope, I have -2/3. So I have y, and then I have -2/3x minus 4 would be the line part. It is solid, so I know it has an or equal to. And the area that's shaded is above the line, so that's the greater than. Another way to look at it is, here's my y-intercept at -4. Here's a point in the region. That y-intercept is larger, is a greater number than the -4. So we know that it is y is greater than or equal to -2/3x minus 4. Okay, to determine this inequality statement. So now I'm looking at those special case lines. So with this special case line, if you can remember, this is a horizontal line, so the slope is 0. So again, just pointing out a couple of things. Our slope is 0. Our y-intercept is 3. By looking at this graph, you should have been able to tell right away that this is like a y equals 3. Is that basic linear equation. We have shaded above the line. Another way to look at it, here's my y-intercept of 3. Here's a point in the shaded region on that y-intercept, or on the y-axis, and it's larger. So it is y greater than 3, not greater than or equal to, because it is a slotted line. So that would be the equation, the inequality statement to represent this graph. What about this one? Very similar. What we have to remember here is this is an x equals. So this would be an x equals -2. In this case, it's an inequality statement, and we can't go above or below the line because it is vertical, but we're going to the left. So that tells me it's a less than. So this is x is less than -2. This is your special case. This is the one type of line that you're going to have that is not a function. The following give you some questions to do from your textbook to give you some practice in this lesson.